At the time, I was on the first robotics team in Traverse City. I actually got lured by one of the Lake State recruiter that came to my high school, and he was talking about robotics that Lake State was big in. And so I did my research on that, and Lake State definitely was. It was 1 out of 3 in the country that had an undergraduate robotics specialty. My name is Ken Casperson. I'm from Traverse City, Michigan, and I studied electrical engineering at Lake State with a concentration in robotics and automation. My concentration at Lake State was robotics, so that entailed a lot of control systems. I learned a lot about manufacturing and various processes. We did a lot of robotics programming and vision systems. I didn't end up in robotics, but I was able to translate a lot of that, especially the control systems experience, into what I do here. I would definitely recommend to somebody who's getting an engineering degree and looking to get into the field is to find something where you feel like you're doing good work that contributes. We have an important job here, making sure that the grid stays healthy and active. It's something I take a lot of pride in, and I always thought that was one of the things that made me want to get into power in the first place, was feeling like you're doing something that a lot of people literally couldn't live without. Engineering tends to be such a specialized occupation, and so what a good engineering education does, I think, is really give you a tool set, what you need to be able to learn what you're going to be doing in your career. At least at Lake State, I know that people are getting the hands-on experience. People are wiring things up in the lab, making them work. So I think those engineers are well prepared for the sort of things that we need people to do. I'd say Lake State redefined a classroom in a sense that I got to go in and actually work with a robot at any given time. You always got to take whatever you were learning and go apply it somewhere. I liked it a lot at Lake State. I thought it was, especially you get into the engineering department and it met with a lot of people who have the same majors. One of the earliest times where I kind of felt like, oh, these are my people, I went there and I met with some of the faculty, and I liked the campus, I liked the classes, and I really got to know a lot of my professors pretty well. All the professors are engineers. Most of them have done work for companies, of various types, either manufacturing or some kind of design. So I was really able to relate a lot. One of the great things at Lake State was always the amount of lab work we did. Pretty much every engineering course has some lab aspect, and that was a big thing for me. When I went looking for a job, I went looking for the same thing, a job where I was going to be able to put hands on, set things up and see them work. I guess one thing I always liked about Lake State is that it felt like everything was practical in some way. The professors really did a good job, and there was a really big focus in trying to relate everything back to what you're going to do. Or I know here's all this math you have to do, but here's why, and here's where you're going to use it. But the senior projects is really the best thing you do in your degree. It's the hardest thing you do, but when you get into working and you get into the real world of engineering, you'll really see how useful it was. But most projects at Lake State are contracts from a company somewhere out in the world that's asking Lake State to provide engineers to solve a problem, build a prototype, something along those lines. Ours was actually from 3M, and they developed a new type of mirror to apply for solar applications. My team had 5 people, so we had 2 mechanical engineers, 2 electrical engineers, and a computer engineer, because our project was very cross-disciplinary. We designed a solar cell, photovoltaic module to put on people's rooftops, and it had mirror concentrators that would track the sun and using 3M's mirror film. So it was a proof of concept to show that their film, which didn't reflect infrared energy, would be able to allow for concentrators of that type without causing necessarily the same degree of overheating problem that you get with most mirror systems on solar panels. They tell you the senior projects is going to be, you get all these dire warnings and everything, but I really enjoyed it, and I think that it really does give you the best idea out of everything you do in school for what it's going to be like. We had an office set up. It was really like working at a consulting engineering company. One question I get sometimes is someone will come up and they'll say, well, you're an engineer, so what does an engineer do? And that's always kind of a difficult question, because we do a lot of things, and some engineers design products for market. Some engineers, like I do, most of what I do is maintaining and ensuring that something that's out there works correctly. If you're going to go to school to try and become an engineer, I think it helps to keep an open mind. You go and you want to be an electrical engineer, and that could mean anything from do I want to program work cells? Do I want to design robotic installations? To do I want to work on high voltage power lines and make sure that our electric transmission grid is secure? A lot of times it just says engineer on your title, but that really doesn't say much about what you're going to do. So even if you pick one field, one of the big three, electrical, mechanical, and computer engineering, you can really take that into working in almost any industry that you could think you want to be involved in. Especially if you're looking to get a start in the power industry, you're going to have a really easy time finding a technician job, because it is very difficult to find people these days with the hands-on skills and the electrical engineering aptitude to work on the maintenance of a system like this. I'd absolutely recommend Lake Superior State. It certainly was worked out for me. It taught me what I needed to know. I got into a good career immediately out. In fact, there wasn't a person in my graduating class of engineers who didn't have a job offer, if not more than one job offer, before we graduated. So everyone I know was able to get into a good job right away, and I've definitely done well in the industry since then. My first job, actually, when I got out of school, was with a power company. I worked for Cloverland, which actually is Lake State's power company. I knew, I think just about from the first time I stepped into one, that what I wanted to work on was high voltage transmission. So after I'd gotten some experience in the industry as a technician, as an engineer, I kind of kept my eye out for job openings and opportunities. So there are always opportunities at ITC for young people with talent, and I knew that ITC was the transmission company that served the Lower Peninsula where I grew up, so I kept an eye on the postings there, and I saw one come up and applied and got the position. I always really enjoyed it from the beginning, because the transmission yards are the big ones. They're the ones with the complex relay systems. You get to go in there and you can hear the hum of the transformers. Right now I'm working for ITC Holdings. I work in Novi, Michigan, and most of the work I do is on the high voltage 120 kV and up electric transmission system in the Lower Peninsula of Michigan. So what you see in the background behind me, this is actually Quaker Substation. It's not necessarily one of our largest stations, but I always kind of feel like this is our station, because it's the one that's right outside our building. It's the one I see just about every day. But it's a good example of the sort of things we have. A large transmission yard. There's a house out there where all the relays are kept, and the relays take all the information they get from the small current transformers on the breakers, and they watch the line. ITC is a growing company. We're looking for opportunities to build more transmission lines. That's what we do, is we improve and expand the transmission grid, expand its capabilities, its performance. I also do work on the system that we've been building out in Kansas and Oklahoma. My particular department is called Relay Performance. This is our relay lab, and this is sort of the modern solution to the problem of how to protect the power system. The group's called Relay Performance, and it's our job not to necessarily design what gets installed, but to make sure that it's working right when it goes in, and that it continues working correctly into the future. When anything goes wrong, we're there, and before it goes in service, to make sure everything's working correctly, we're there. So one of the biggest projects I've worked on is our 345 kV thumb loop. I was just working on the commissioning and just the final checkout of getting that very large project going. We have to go through, and I work very closely with the field technicians, making sure that all the relays that are installed are testing correctly, that all the communication channels are working, all of our fiber optic communication channels and whatnot for the relay protection are working, so that once this thing goes in, we know that it's going to be working the way we designed it to work. Growing up, my dad was an electrician, and one of his biggest things was always getting to see the lights come on at the end of the day, when you wire something up, and having it actually work.